Okay, I think we can start now. So, good evening, everyone. This is Samyuktha. I'm the Secretary of Razor. So, I'm joined here with Aditi, who's the Deputy Secretary, and Isha as well, who's one of our coordinators. So, thank you all, first off, for joining today's spotlight session. So, this is essentially going to be a space where we highlight the work of our members and the work they've been exploring and give them a platform to share their ideas, their curiosity, and the effort that they've been putting in sort of behind the scenes. So, today we have Abheek Soni and Rathish Manivannan who'll each be walking us through their research explorations. So, really excited for both of them to get started with. So, let's dive right in. So, who'd like to go first? Abheek, perhaps?
Yeah, sure. I'd love to go first.
Thank you.
Okay. Hello, everyone. Myself, Abheek Soni. I'm a student of the IIT Madras BS degree. I'm doing a dual degree. My second degree is from Shankaracharya, Raipur. My interest is particularly in nuclear physics and anything that involves learning. Hence, I'm very delighted to be a part of the Razor Society, and I'm extremely delighted that I am given the chance to share my presentation in front of all of you. Excuse me if this camera dies because my laptop does not have a built-in webcam. I'm using an external cam, so please excuse me if it dies in between the session. So should I just begin with my presentation then?
Yes, Abheek. An
Okay.
introduction would be good.
So yeah, before I actually start, I'll briefly tell everyone about my topic. So particularly in my topic is vapes and how to recycle them. I'm not really discussing the scientific aspect of how to recycle vapes. Instead, this is sort of a market research which explores how can we capitalize off of the waste that is being generated by the vape industry. So with that, I'd like to begin with my presentation. Is my screen visible?
Yes, it is.
Okay. Starting off, the unseen crisis, vapes and our environment. So, vapes were once hailed as a healthier alternative to smoking. It was initially intended for middle aged chain smoker men. It was meant to help them quit smoking by providing them a safer and less harmful alternative that still provided the same sensation as smoking. But unfortunately, and partly due to social media, vapes have infiltrated youth culture. Particularly among teenagers, the vaping has become sort of a cool thing. So this is the harsh reality about the youth vaping epidemic. I'll explain why am I calling this epidemic later. So the number one problem is widespread abuse. Uh, Smoking and vaping inside of schools and colleges in some countries like the US and the UK has become sort of a social media trend, and students are abusing this as a cheap thrill, even though vaping is completely banned in any school premises. Second thing is social normalization, which I think is the worst issue in relevant to this topic. Because of social media, vaping has unfortunately become a cool thing. People think that it is cool to vape. This is a huge problem in youngsters, especially in school students. The third is epidemic proportions. Why am I saying this epidemic proportion? Is that the entirety of Gen Z, if you go 2 to 3 years back, when the vapes were getting popular, it was a sudden shift that uh, the entire Gen Z who didn't even like smoking all of a sudden starts thinking that vaping is cool. So instead of vapes helping people quit smoking, they turned into an epidemic which caused the entirety of Gen Z, well, not entirety, but the majority of Gen Z to either start vaping or at least appreciate vaping, or they think that vaping is a cool thing, even though it is seriously unhealthy. So this is why I'm calling this epidemic. You can see the numbers, I'll explain them. So the number one thing is that at least 150 million vape devices are just discarded into the US annually. The number 150 million may seem big, but it is small as compared to the amount of waste that is being discarded annually all over the world. Now, I have mentioned that it is discarded into US landfills. The thing about the thing about US is that US does not like e-waste in its own landfill. Countries like the US, the UK, and many first world countries, they like to do this thing. They take all of their e-waste and they either sell it or they donate the e-waste to third world countries. And I don't really have a reason as to why the third world countries accept this, but they do. And the e-waste, which is donated to the third world country, just sits inside the third world country's landfill, and over time it just causes more and more and more problems because a third world country already has enough problems to deal with, and this landfill just makes matters a whole lot worse. Second huge problem for us is that just in the us just in the us 5 vapes are disposed every second. Yes, 5 vapes are disposed every second. So you can just imagine how much waste is being generated per year. And this is just US alone. US alone is basically throwing away 5 vapes per second. The third most disturbing fact is that the amount of lithium batteries, uh, the amount of lithium that is in the batteries of the vapes that are discarded annually is enough to make batteries for 5,000 electric cars. So, expanding on the lithium and why the wastage of lithium is so bad, because the entire world is trying to go electric with electric vehicles and our smartphones, our devices, everything is getting smarter, everything is involving electronics. And again, electric vehicles are one of the best step in the right direction towards a greener and cleaner future. But we need lithium for anything that has batteries in it. For example, this camera, this Bluetooth keyboard that I'm using, the laptop that I'm currently using, all of our cell phones use lithium batteries, and lithium is a precious but limited material. And to see that tons and tons and tons of lithium is just ending in landfills, this is truly disturbing. Not only that, when lithium is just thrown away like that in landfills, it interacts with the environment, and lithium has a tendency of degrading. Even your batteries degrade over time. That's why you may notice that your laptop that is 10 years older may not hold its charge as well, because lithium degrades, it inflates, and when it inflates too much or it degrades too much, it has a risk of exploding. That is why a lot of Samsung phones exploded, because lithium is a very very reactive material. So when this lithium leaches into it, seeps into the ground of the landfill, it poisons the soil, the water, the air, and every creature including humans that is around the landfill. That makes the third world country's landfill, or any landfill, then the area around the landfill, so much worse. So we have a dual challenge. One is the addiction part that is in the teens, and second is the environment aspect. We are not here to deal with the addiction part because I am I am more concerned about the environmental aspects. Uh, there are certain brands, not brands, organizations, certain private industries that are dealing with this vape disposal things. They are trying to recycle the vapes. They are trying to take care of the disposal. But overall, the vape industry is no way even concerned, even close to concerned about the vapes. They just throw it away. And again, donating or just selling the vape products to third world countries is significantly easier and cheaper for the vape industry and the country, instead of actually trying to recycle any of that, any part of the disposable vape. So they just throw it away. There are organizations that are trying to recycle, but the sheer scale of the vape industry's wastage is so large that the current market is just way too small for the industries to actually try to recycle anything effectively. So, seeking solutions, global approaches to vape waste. Several countries are struggling with the vape prices. Like I said, the countries like US and UK are producing ungodly amounts of disposable waste because of the vaping industry. And how India dealt with the vape is actually quite genius in my opinion. India just flat out completely banned the vapes. In India, it is 100% illegal to buy, sell, import, export, or even possess a vaping device. Although it is not punishable by law, it is still considered illegal. But however, in countries like the US and the UK, vapes are widely available. They can just buy it off a regular store, like it's just a pencil or something. Even though there are age restrictions, but that don't really do anything. So those countries may not be able to just completely ban the vape products. So that means that in the upcoming years, maybe in the next 10, 20, 30, 50 years, we will continue to see this huge influx of vape material that is just thrown away. So this is where our vision comes in. Basically, what our vision is, have a US processing unit break down the vapes into its components, such as the plastic casing, the metals that are inside, and the battery components, such as lithium or other metals that may be used in the battery. Maybe it's cobalt or something like that. And then that factory will export the waste materials to us in India. In India, then we can have a factory unit that will use those products, and we will recycle them and uh, repurpose and recycle them to make actually useful products. For example, we can make plastic chairs that are widely available, and I am 100% sure that everyone who's present here or everyone who is listening or watching to this meeting has seen one of those red or white chairs that you see in all public events. If you go to a wedding, any public event, or any school or college event, you will spot red and white chairs that are made of plastic. They are cheap to manufacture, they are cheap to buy, and they last relatively a long time. They get the job done for a cheap price. So we can use the plastic that is coming from vape to make plastic products like chair or plastic baskets or things like that. And usually the plastic casing of vapes are made of two material, HDPE and PET. HDPE can also be used to make raw material for another industry, which is the agriculture industry. HDPE pipes are widely used for irrigation pipes, so we can use waste material from the vapes to make raw material for the agriculture industry. Secondly, PET. PET is very common in our water bottles or 3D printing filaments. So we can take waste material, the waste plastic body of vape, and turn them into raw material for plastic bottles and 3D printing filaments. And then we can sell this product back in India or to neighboring countries, or maybe we can even hope to take the waste material of US, turn them into a good product, and then sell it back to the US for a even higher price. So turning waste into value, the recycling opportunity. Again, while direct imports of vape in India is completely illegal, that is why we are trying to approach a two-pronged approach. One will be in the US, one will be in the India, and both of them will work together. A processing unit in the country like US will dismantle the vape, separate the components, send the waste product. It is waste for them. For us, it will be the raw material, and we will recycle all the material, turn them into product, and then sell them. So one question that everyone may have is that why vapes? Like why only vapes? Why am I not talking about any other materials or in general anything? So I am, or at least another person who is with me in this business idea. Basically, we are trying to capitalize on a neglect. The entire vape industry and countries like the US, the UK, Australia, and anywhere that is allowing the use of vape, they are completely neglecting the waste material that is coming out. Like I said, the US is disposing 5 vapes per second, but it is not even worried about where they're going to throw the vapes, because they just throw it into third world countries and then it's not their concern anymore. This is where we think we can step in, and we will be helping a lot of people here. First things first, let's say we buy off the waste product from US. We are taking care of US's waste product. US is happy. We make products, we sell them into other countries and maybe even our country, we are manufacturing in India. I am generating revenue in India and for India. So I become a supplier of not only products, but I also give job opportunities to people who live in India. And thirdly, I indirectly helped a third world country by not allowing the waste product to end up in their landfill. So this is our vision. This is where we think we can capitalize in. The neglect is a huge part because the industry is so neglected. I think we can step in and turn this into a huge profit. And from landfill to last time, closing the loop, we acquire waste, recycle and repurpose, and then we sell it. So this was basically my presentation. Thank you.
Abheek, first off, that was a really emphatic presentation. We talk a lot about the behavioral issues that go underlie vaping, but
Yes.
never have we come across a presentation that talks about the environmental impact. And you have managed to do that. So, a question that I want to ask is why is this the problem that you've chosen to focus on? Why vaping and why waste in particular?
Okay. Yeah, like I said, because I see that this industry is completely neglected by anyone and everyone. An average person who is using a vape is not thinking about where that vape product is ending up. The company that is manufacturing the vape is also not concerned about it. The country that is allowing the industry to flourish is not concerned about it. The only people who are concerned is who are actively looking into it. I looked into it and I am seeing that the US, let's say the US, they are making so much vape waste and they're just throwing it away. And I see that those materials can be used to make actual good products. And one question also arises is why vapes? Why not other products? Because other industries are not as neglected as this one.
A slightly personal question, if you don't mind. So, what made you
Yes.
look in this general direction?
I It's a combination one of things. A few videos I saw on YouTube which in which a person repurposed vapes to power his entire house. All he needed was just 500 vape batteries, and he was able to supply electricity to his house for an entire day and his shop. And some videos show that they made a gaming device out of vape, which made me believe that we are thinking of vape as just a disposable device. You use it to smoke and then throw it away, but we don't realize just how many precious things that are inside the vape. So some inspiration was from the YouTube video, and then I started to look into it. Then I realized, okay, there is a huge potential. So that made me research into this topic.
You never know where motivation will strike, right?
Oh yeah,
So, any other
absolutely. It was a
questions, anyone?
random YouTube video that made me motivated enough to look. And yeah, from there I have done a lot of market research. Hopefully, I'm able to turn this into a business.
Anyone? I guess I have another question for you. You had mentioned that the third world countries, so they are the places where the first world countries sort of dump their vape waste. So, do you have any idea as to why these third world countries accept them? I know you had mentioned that you're not really sure, but if you were to guess, what would it be? Am I audible? Great.
Yeah, my headphones were disconnected. Could you please repeat your question?
Sure. So, during your presentation, you had mentioned that the third world countries are the ones who are sort of accepting all of the vape waste from first world countries like the US and the United Kingdom. And you
Yeah.
had also mentioned that you're not very sure as to why these third world countries are accepting them. But if you were to make an educated guess, what would you say it is? Why are they accepting it?
Okay. Number one would be corruption in the government. Um, and like I think I mentioned it that the first world country donate the e-waste to the third world country. So on paper, they try to represent this transaction as a donation, and they try to pass it off inside the third world country as a good thing, and the first world country also tries to pretend that they're doing a good thing towards the third world country. That would be my guess.
Okay, so you're suggesting that the first world countries are sort of framing it as a donation activity, wherein they feel like they're doing a favor to the third world countries, and the third world countries are naive enough to accept them, right?
Absolutely, and this isn't just a new thing, or it's not a thing that is only happening in the vape industry. This has been going on for years. It's been decades since the first world countries have been offloading their electronic waste into third world landfills.
And do you have any statistics on sort of which third world countries they're dumping hotspot?
Not exactly. I have, because this detail is not 100% widely available, but
Okay.
some third world countries I think I know are South Sudan, and yeah, I think I can only remember one, that of South Sudan.
Okay, okay, all right. So, talking about the research itself, what was the process like for you? How did you go about this?
I would say the process was very linear actually. I just went on from one article to another and got to learn a new thing. And then I wrote everything down on a notebook. And each day I tried to research as much as I could. And I made a few presentations. And at each step, I made sure that my resources were correct, because getting the statistics wrong in a research like that can be catastrophic. So I don't think I linked my references in the presentation, but I had a lot of references. And the number one thing that I try to do is read as much as I can, and as from as many sources as I can, so I have a broad idea of the topic.
So you had a wide base and then you winnowed down. How did you ensure that you verified them correctly?
I verified them by using, I say, I don't know if it's an exact method or something, but let's say I found a headline in a news article that say US
Mhm.
is disposing 5 vapes per second.
Mhm.
I took that, I wrote that into my notebook, and then I went on to some actual trusted government sites. I don't remember the exact domain name, but
No
the
issues.
Canadian government and the US government have certain website that is dedicated to researching about this. And I checked on their articles and the numbers looked similar. Secondly, I what I did is that in the news articles itself they had linked some research papers of some world health organizations and other organizations like that. So I looked at their papers as well to verify that the numbers that I am writing in my presentations are correct.
Okay. All right. Anyone, any other questions? I guess not. I guess a final question, sort of a curiosity from my side. So, which stage of the waste generation process is your business tackling right now?
Stage as in,
I mean, what are you doing right now as a business?
right now we don't even have a business. It is just a market
Okay,
research
okay,
before we
okay.
go into business.
All right, all right. All the best for that. And yeah,
Thank
this was
you.
a really insightful presentation. Great answers too.
Okay. Yes. Okay, thank you.
Thank you, Abheek. Our next speaker is Rathish Manivannan. Are you here, Rathish?
Yes, am I audible?
Yes, you are.
All right.
Would you like to go ahead? Yes, thank you.
Sure. Can I share my screen now?
Yes, please.
Okay, so is my screen visible to everyone?
Yes, it is.
Okay, all right. So, good evening, all. So, here I am Rathish Manivannan. So, basically, in regard to IITM BS, I have currently completed my diploma in data science, and I'm very excited today to present my presentation at the Rasor Society's R&D wing spotlight session. So, in regard to my introduction, I am a final year BTech student in computer science and engineering with specialization of Internet of Things at Shivnadar University, Chennai, Tamil Nadu. And as I stated earlier, I have completed my diploma, and I am currently in the diploma level of the IITM BS program. So, my major interest revolve around A-based IoT solutions in real time, in life, residential, and also industrial purposes. Okay, so today the topic that I'm going to be presenting here at the spotlight session is AIoT in occupancy detection. Okay, so now let me give a small intro into this topic. So, as we all know, we are humans, so we are a dynamic resource. We usually tend to move from a place to another. We don't be tending to be in the same place for a longer time. So, while considering either a residential context or an industrial context, if we see if we move out of a room, it is very easy to the we forget that to off our lights or fans or our air conditioners or the HVAC systems, so anything in that sort. So this is and as per the recent statistics, they are telling that around 40% of the energy waste is mostly due to buildings. So coming back to the point, so here the topic rise around. So what we in this system, what we are trying is that we are using A and IoT based solutions for doing for detecting the occupancy detection in a particular environment. So based upon that, we are trying to control energy and optimize it. So this is the major problem statement we are revolving around. So how before starting on, I will tell you how the presentation flow will be like. So in this domain, I have researched quite a number of papers from 2018 to the current till date 2025. So it will be more or less like a literature review only, but I will be telling what were the limitations of the earlier thing, what they tried to improve, what type of technologies came into picture, why that was important, why it was neglected, then why the next came. So I'll be telling it like a story kind of thing, so that it will be easy to understand and interpret from the insights. Okay, so occupancy deduction. So as I stated earlier, this occupancy deduction is not only meant for this energy optimization or energy conservation kind of thing. If you move out of the room, the fans and lights should switch off on its own. So that's one point. But it can be used for the emergency evacuation purposes, and also it is used in smart buildings. So it has so many real-time applications in the current day. So, okay, so in traditional based systems, how they were doing it? Because before coming to the current thing, we need to be understanding what was happening in the traditional based system. Either it was done in an intrusive manner, or else camera based solutions were provided. Okay. So if I would like to ask to everyone whether you would be liking to have a camera in your room, always monitoring you, which also hampers your privacy. So most of them won't prefer that, right? Because having a camera in room always monitoring you in a continuous basis, it is highly difficult. So it won't be highly private for you as well, and you can't perform your everyday tasks. So considering these points, only came in gave an option for the entry of AI based IoT solutions. Here only the sensors came into the picture. Here only deep learning approaches came to the pictures based upon the sensor data. So, so the first thing is that we need to be having non-intrusive based occupancy detection. There should not be any kind of physical touch, or else there should not be any kind of privacy issues. So here the role of sensors come into play. Here, the role of IoT comes into play. So first of all, the first paper that I have shown on the top of the slide is that it's a 2018 paper. So in this paper, they were basically trying around the basic sensors in IoT, such as the noise sensor, DH11 temperature sensor, and they were trying to collect the data out of it, and they were trying to apply some basic ML models like random forest, and they are trying to find out the occupancy detection. How many persons are there in the room in the current situation. In the current instant, that is important. They are for earlier stages, we were trying to compute it for the current instant. So then they slowly trying to improve the systems level. Then they try to improvise the quality of the sensors. First, they started with the basic sensors. Then they tried to improve the quality of the sensors. Then they brought into Doppler radar sensors that is based that uses the changes in the frequency for detecting the occupancy in the room. And they brought in thermal array sensors that uses temperature as a criterion. And they trained those data on deep neural networks. And they recorded the outputs, and they were tried to identify the occupancy for a confined small environment. It can be basically lab testing kind of environment using this basic kind of sensors. Then coming next in 2021, what they tried is that the scholars they tried it with PIR sensor. So in IoT, PIR sensor is a position that is used for detecting the motion. So if any movement is found, it will immediately detect and tell us. So that is the basic usage of PIR sensor. So when they were using PIR sensor in such an application like occupancy detection, what they found is that it tends to provide a lot of false negatives. Okay, so what is here false negatives? Because if you see, if I'm moving my hand like this, waving like this itself, it will detect it as a movement, and it will immediately switch the lights off. So it should not happen like that, right? If I move out of the room, then it should be testing and telling me that I'm out of my room, so the lights and fans should be on. So for simpler movements, it was giving false outputs. So that's why I'm telling it is here it has false negatives. So for that, they tried to improvise the level of PIR sensor, and they created it using a synchronized low energy using liquid crystal system. So this is the thing. So here now in this slide, what I try to show is that how the camera-based solutions were slowly trying to replace using sensor-based solution, and how it slowly advanced over the ages. Okay. Now let me talk something about the AI, because I am talking both about on the regard of AI and I also IoT-based solutions. So based upon AI, now I'll give us a short note. So first, for energy monitoring, the first. One of the initial deep learning models after ANN that was being deployed was LSTM. So why long short-term memory would have been used? Because it has the capability for temporal dependencies. So what is done is that the previous data in the same environment is being trained, and the main feature that has been used earlier is the CO2 concentration data. So as you know, humans inhale oxygen, exhale carbon dioxide. So based upon the carbon dioxide concentration data in the room, over the time, we can tell whether the person is there in the room or not. So they tested in a confined university lab test environment, and they got an accuracy of 70% using LSTM. So what they did is that in the particular instant of time, the model will be trained, previous data which is trained, it will be checking on the CO2 data there. If based upon the data and the trained model, it will tell whether the occupancy. If the occupancy is, if there is no occupancy, then the fans and lights will turn off. This is the basic system around it. Okay. So as now I talked about a small university lab test environment, this is for a large exhibition hall thing. It is nothing more complex than the earlier thing. What they did is that they took a big hall kind of thing, an exhibition hall. So the exhibition hall, they broke it into several components, like using spatial partitioning method. So they made it into multiple zones, and each zone based upon the data, they trained the RNN with the recurrent neural network with the long short-term memory models, and each term they checked for the short-term and long-term occupancy detection. So this was done. So for each zone, they trained the model, and they found out the occupancy, and based upon that, they optimize the energy. And some other techniques that were being used earlier or before this was blended Markov chain, hidden Markov model, and these were also being used based upon the thermal data and also the carbon dioxide data, which I stated earlier. So these were used as a features, input features, the carbon dioxide data, the thermal data, temperature, noise, vibration. These were using the input features, and our output feature for the model is the occupancy of the room. So based upon the occupancy, we can optimize the energy. So that's the whole thing here. Okay. So here, so this next slide, slightly it moves from data of only from the sensors part, and here we are combining the data from both temporal and sequential analysis. Here, what we have done in this particular research paper, what they have done is that they have both took temporal data based upon the time and also the sequential nature of the data. For example, they have used hourly occupant data from 16 different buildings, and they have separated into seasonal periodicity. I will show the architecture diagram that I took from the paper so that you can have a better clarity. So this is based upon the different environments that were considered: the railway station, airport, commercial complex, and hospital, and the different kinds of features were being extracted on a different temporal dependencies for a daily or as weekly or a seasonal basis, and also temporal correlation was calculated, and both deep learning model ANN and also random forest was been compared for occupancy detection. Okay, so this was combination of both temporal and sequential analysis using deep learning and machine learning algorithms. So in this paper, what they tried is that it is the progressive paper. Earlier we saw about the sensors. Next we saw about the deep learning techniques like LSTM, how it changed the place. Then we saw now about the temporal sequential analysis. Now what they did is that they tried, as everyone knows, basically in machine learning there are two things. One is regression and classification. So for this same system, they also tried regression for the calculating the arrival time, and also classification for occupancy state prediction. And based on these both, they in this particular research paper, they used decision tree, KNN, MLP, GRU model, Gated Recurrent Unit models for comparison. And what they concluded from this paper is, from in comparison of computing the arrival time using regression-based techniques, the classification-based techniques for occupancy state prediction was relatively well. The classification systems was relatively performed better in calculating the occupancy in the particular environment. Okay. Now, still now, what I have taught, if I want to justice that sensors-based, IoT-based, the deep learning techniques that were used, and then the temporal sequential analysis, which I told, and the classification's importance in the overall detecting of occupancy detection. So these all things were done to find the occupancy in a particular instant of time. If I have the previous training data, I am training and finding the current time. But if, as I stated earlier, if I want to use it for emergency evacuation kind of systems, what I need to be having, I need to be doing some kind of forecasting. I need to be finding it for the future time steps. So this is one of the earlier papers that tried to imitate that, or try to do that. So what was done in this paper is that they also, based upon the data set they have collected from various environments, they tried to delete some of the rows of the future data. They created missing data and of 1 day and 2 days, 3 days, 4 days. So they made many of the data missing in the data, and they trained that data. So they did not provide the data completely to the model. So if we provide it completely to the model will know everything what will be happening before a week, next week, so it will be having a data access to everything. So what they did is that they deleted some parts of the data and they gave it back to training. In somewhat what I can tell is that they try to imitate that it can forecast also. So, and based upon that, they checked for the 1 day and 1 week forecast using hidden Markov model based upon the features that they have trained is CO2 and sound decibel levels. So they got an yield of 82% and 81% respectively from this particular research paper. Next. So now we are coming back into forecasting. Forecasting is that we need to be finding the occupancy in the next time steps. So here, for an occupancy-based detection in next like a forecasting method, now using our earlier STM model, now they are trying to optimize even more effectively by using bio-inspired optimization algorithms. So it is a set of optimization algorithms, but what they used is that they used particle swarm optimization and also genetic algorithms, and combining these with the existing LSTM network that was used for detecting the human occupancy, it provided better and even more effective performance in detecting the occupancy of a particular environment. So these are basically the results that we got from the research paper. Okay. So hereafter, these two papers are particularly from the 2025. These both are from IEEE Explore only. So this paper is that these both papers why I have chosen is that they both were used using the same public data set for their training and for deduction. But one paper uses RNN based LSTM and another uses transformers that will be explaining consecutively. So the data set, how it is done, it is a public data set of 6 single family homes. So 6 family houses data is there, and the several sensors are taken into account. And the data has been sampled for every 10 seconds. And during the pre-processing stage, it has been resampled into 1 minute intervals, and missing values have been removed and handled. So in this particular paper, using the above public data set that was published in 2021, in this data set, the one thing is that they were having data in regard to the sensors data, the camera, the video, and all the other data that is happening in the particular home. So, but the authors were only interested in choosing the data from the sensors for occupancy detection, for emergency response system, as well as this energy optimization. The reason that was stated in reviewing this paper is that the author suggested that they want to feel the residents and the industrial people even more secure, and they will even more their privacy should be preserved. So what they did is that they eliminated all the camera and audio visual types of data from their model, and they only took the sensor based data and they trained their model. So what their major motive is that by using the sensor based data without taking any camera based data for training, so that the privacy of the people will be preserved. So that's the main intention. So that's why AI-based IoT solutions using sensors and applying models on them could save our privacy, and also it could be used for occupancy detection in energy optimization. So as I stated earlier, now we are doing forecasting based upon LSTM, and we are deducting the next occupancy detection for 0 to 4 occupants. This particular paper discuss only is restricted to 0 to 4 occupants in the next consecutive time steps. So these are basically the results of the paper and the methodology that they have been used. The basic pre-processing that I explained earlier, and also the model that have been applied. Then some important points on this paper. As I told, there are no audio visual inputs that could hamper the privacy, only based IoT based sensors, and also they have used comprehensive hyperparameter tuning. And also, instead of deducting, as stated in the earlier papers, instead of deducting whether human is there or not, they are doing it as a multi-class classification from 0 to 4. This paper is restricted to 4 occupants only, not just present. They are not just like a binary classification. They are doing it as a multi-class classification, which is an additional point about it. Next, this particular paper also on the same context, on the same data set only. That also preserves the non-invasive and privacy nature, but on the same data set. But here what is done is that instead of using LSTM, now the authors have slightly moved above, and they started to use the transformers here. Why transformers have been used? So transformers, the authors have stated that they need the attention mechanism. That is because they need the parallelization approach for faster deduction. And also in this transformer, generally encoder decoder transformer will be used, but here only encoder is used because the output is a single value. The single value is what? The single value is the occupancy of the particular room. So based upon the previous time steps, we are trying to forecast for the next few time steps of occupancy, so that we can take some actions in prior to that, or we can conserve the energy, or we can take emergency response in prior to that to prevent any kinds of hamper in the future. So that's the major intention of the total work, and also this paper also. So these are the results for this paper, and for each, as I told it, 6 houses the data was cleaned, and each houses, these were the accuracy that was recorded by the authors. So okay, now these basically capture the temporal dependencies, as I told earlier, and also the applications, the real-time applications of these kinds of systems. It is for smart building management, predictive energy optimization in that, and also emergency evacuation. If any changes in the values, we can observe changes, anomaly can be observed, we can take immediate actions to prevent future crowding. And also these kinds of using sensor data with AI-based sensor data can prevent us using real-time camera or audio-based inputs, so it can preserve our privacy also. So, in my overall picture, some future works that I suggest for future people they might be doing is that for four now the as I stated earlier they are doing for 4 occupants, 6 occupants kind of thing. No, we can extend the occupants for a large number, and also we can do it for a multi-step for future forecasting. And also the LSTM and transformer models could be integrated to a hybrid framework, and also evolutionary optimization algorithms could be incorporated instead of bio-inspired optimization algorithms for better effectiveness in capturing real-time dependencies. So this the overall conclusion I would like to give. And the major stake of this work is that this research from 2018 to 2025, I'm telling these kinds of technologies use, sensors use, models use. But the major thing that we are trying to focus here is that we are trying to make our static buildings to some kind of cognitive buildings, so that instead of using a building as a shelter, we can also optimize the energy in it, and to get a positive results out of it to enforce the SDG goals that are stated by the United Nations for a positive tomorrow or conserving the energy in a future purpose. So that's all that I have to say. Thank you all for the opportunity.
Thank you, Ratish. That was wonderfully presented. So my first question to you would be, what motivated you to work on this problem?
All right. So the motivation. So actually, I'm an as I stated earlier, I'm an IoT based student, and also I'm a final year student here. So my working from my first year onwards here is basically upon AI and IoT based solutions on either industrial motive or else residential motive. So these kinds of work only in my second year I have done based upon touchless doorbell on face detection. I have presented it at Springer conferences also. So my work itself relies in around these topics only. And another thing is that kind yeah, everything should start from our home, they will tell, right? So that's the major motive here, because we need to be first solving the problems around ourselves. Before solving the problems around ourselves, if we are going outside and seeing other issues, there will be no much thing, because we are itself having plenty of issues to be solved. So if we see our small home, our small room, we will get many issues in real time that needs to be solved, and many new things that could be innovated out of it to get a positive tomorrow, or to get a positive success to maintain sustainability in the future.
Okay. The other question that I wanted to ask was that about your research was what was the biggest challenge that you faced in your methods?
Okay, so as I started earlier, this work today which I presented was a basic review only. So I was from I referred several papers from starting from Elsevier to ESI, Web of Science, and also Scopus, and also IEEE. So various indexing agencies and also various publishing platforms. I consolidated those papers, and I only took the recent papers from 2018 to 2025. I tried to make a logical, coherent flow from it. So to make it as a story so that I can understand it. So these were the major difficulties, because we will be finding plenty of papers in this regard from an earlier ages also. But what we need is that we need to be finding the limitation in each of the paper and how it was solved by the next paper, because there could be multiple replicative papers in the same context also, but we need to be finding the paper that made the real progress from the earlier version. So that is the major challenge. That's what I feel.
Okay, that's a great answer.
Just a second, I have a question in this regard about the limitations that you mentioned. So you said that you referenced a number of research papers in your review. So did you personally notice any limitations or gaps that stood out to you, especially from the perspective of someone who is new to research?
Limitations the system you're talking about.
Yes, in the contents of the research paper.
Okay, so again, coming back to that, if you think now I'm telling, right, so these sensors based approach, I'm taking the data, training on deep learning models, using optimization algorithms, sort of thing. So if you see these, again, instead of using camera-based data, okay, camera-based data, if you use, that privacy issues are there, but even though we will be training on the CNNs and getting some results, it is also highly computation intensive only, and the approach now we tell is also highly computation intensive only. We are trying to optimize energy in some context, optimize energy in some context, but on a longer run, we are also spending energy in some other things. Here, training the model, detecting it time to time in the future. So, we are telling that we are detecting by off, lighting fans off, lights off, ACs off. So I'm talking about that. But in the background, we are training the models based upon the sensor data every instant, every timestamp, and trying to detect the forecast the future also. So there anyway we are spending a significant amount of time. So there also the optimization needs to be taken place. So for that we need to be finding some suggestive methods. So what we can be doing there as well. So that is one limitation, right? On a longer run.
That makes sense. Aditi, would you like to continue, or should I go ahead?
Go ahead.
Okay. So one more question that sort of popped into in my mind while I was sort of listening to your presentation is, you had mentioned emergency evacuation is one of the applications. So could
Yes.
you talk a bit about what makes occupancy detection in evacuation scenarios sort of uniquely challenging?
Okay. Well, that is a nice question only. So, how I am talking about that is that, if you see, if we are having a confined environment sort of thing, and especially in industrial environments only, this will be high, not in residential purposes. In industrial, if you see thermal power stations, nuclear power plants, there are there is a restriction to how many people can be there inside at the same time. So the O2 levels are inside are low, the heat is high, and also the other natural factors that could not be accustomed for the people to be there. So for those kinds of applications, if the number of people is more than a particular situation than there, then we need to be detecting occupancy detection so that they could be evacuated out immediately. And another, can be used for also overcrowding in some of the places. There also it will be highly useful.
So how will these systems work in mitigating that issue? Is there sort of a feedback, or does it like blare out alarms, maybe color signs, something like that?
Actually, the work that they are the authors of they will be detecting the occupancy, and based upon the occupancy and the environment that they are deploying, we need to be setting up condition rules for it, because each and every environment has a different use case, and also it is environment specific. So for each environment, we need to be taking specific set of rules. So if the occupancy is greater than 2 here, what needs to be done for 3, 4, 5. So for everything, it gets varied, right? So based upon that, we need to be giving okay, alarms can be installed, user interface monitoring systems can be deployed, large monitors can be set up. Alerts could be sent, and notifications would be, so anything can be done. But for that, based upon the environment, we will be setting the condition rules. That is important here.
Okay. And talking about the occupancy detection research landscape right now, so from what you've explored, what are the biggest challenges that AI/IoT based systems face when being deployed in the real world settings?
I think I already given a spark on this earlier. So major issue that I told is that the computational power requirement, that is always there. One thing that I always suggest, and another thing is that it has not been the scalability of those solutions is also issue here. So how much scalable is it is, how much whether we can integrate all into a single system. The whatever, as far as research is concerned, they are training on a particular data set. They are and based upon that, they are giving some results. But whether it is the proposed solution could be scalable on an ground context, whether it is helps in real time monitoring, These could be some of the challenges in which we check, especially in the industrial situations that are highly turbulent and dynamic in nature.
Thank you so much, Ratish. Does anybody else have any questions? Please ask if you have any. Okay, I don't think we have any more questions. So, I know you have answered this before, but could you please give us the key takeaways from your research and give some lessons to the beginners in our session right now?
Okay, so uh, in regards to this topic, whatever I have stated earlier is that not the based upon this occupancy deduction also. If you see around your home or in the environment, there are plenty of issues that could be solved using AIoT. There is no limit for that. So if you simply close your eyes and think of for a few seconds, there will be plenty of problem statements. But the main trick is that you need to be finding the methodology. So for that only, either you need to be going with the research papers, or else you can check with the articles, magazines. So there are plenty of resources around the internet. Now, for initial checking, what I suggest is that go through review papers that you on the topic that you would like to work on, because they would have systematically systematically given the limitations, what the earlier authors have done, how they have solved it. So you can try reading few review papers on the topic that you would like to work on in the present. So by studying those, you can get, then from that you can get track to individual research papers, and from that you can try to get out insights, limitations that would have been suggested at the end of the paper. And also you can also find out the limitations by checking with its real-time deployment also, that is provided through either in online, through YouTube resources, and you could also manually test it by train. If it is a software, you can try to train the code that you have provided in your Collab or in a Kaggle. So that could also be done. If it is hardware, if you have an access to the lab, you can try setting up the same hardware components, and you can try to test. So because without doing anything in real time, we can't tell, right? So that can be done to progress your research. In my topic of occupancy deduction, what I have read is that from traditional based system, how they have slowly started to sensors, and from the sensors, how they had started to apply deep neural networks. Then from there, how they moved into recurrent neural networks, and based upon this, when how they did temporal and sequential analysis, how they concluded classification is better for this particular context, and how multi-class classification came into picture, and at last how now LSTM and transformers are used for forecasting the future occupancy for deduction purposes, and how these kinds of applications are used for energy monitoring and also for emergency evacuation purposes. So this is the total outline what I talk, and also the research that can be done, the surrounding topics as well.
Very well researched, Rathish. So, what is the path ahead like for you?
Okay, so the path ahead, I have already suggested few future works as
Yes.
part of what I have researched also in my slides, that I could try, that could be tried. And also I have already stated few limitations in regard to my work, right? So solving any one or two of these could make a phenomenal difference in the real-time deployment of these systems.
All the best for that, Rathish. Looking forward. So, everyone, I think we've reached the conclusion of today's first spotlight session. So, thank you, Abheek and Rathish, for joining in and for enthralling all of us. So, I hope the audience here had a very informative experience. If anyone would like to have any doubts clarified by the speakers, this would be your last chance to. If not, we'll be winding up. All right, then. Thanks, everyone, for joining. Good night.
Samyukta, should I stop?